Hello everybody and welcome back to Advanced Maths. Today we're looking at box plots. So here we have a set of data. It says some people played a game and scored the following points. And we're going to try and plot this on a box plot. Here is the data on the number line. And we can split it into two equal parts, and halfway between those equal parts is the median. The median is a number that splits the data into two equal parts, where half the points are below the median and half the points are above the median. Then we can do it again, and we can split it into quarters now. And we've got the lower quartile here, which splits the first half of the data into two equal parts. Similarly, we've got the upper quartile here, which splits the second half of the data into two equal parts. Notice that now we have the data split into four quarters. 3 pieces of data in the first quartile, 3 pieces of data in the second quartile, 3 pieces of data in the third quartile, and 3 pieces of data in the fourth quartile. We've also marked on the maximum and minimum data points as well. And this is how box plots work. These are the key parts of the box plots. So the minimum data point, the lower quartile, the median, the upper quartile, and the maximum. And this is a box plot here. You will always see box plots have this shape, where you've got the box in the middle and the 2 whiskers either side. Box plots are useful for displaying the spread and dispersion of a data set. So here we've got 2 other box plots to compare. The one at the top, you can see that it's heavily skewed to the left. So the data seems to prefer lower numbers. And it's got a long tail on the right, which means it's got quite a lot of outliers on the right. The data set in the middle seems fairly evenly spread, and each quarter is about the same size, meaning that we would call this a normal distribution or a normal spread. And the data set on the bottom has a small range, and there isn't much dispersion. It's not spread out very far, so low dispersion. The interquartile range is also comparatively small. So let's do an example. Draw a box plot from this cumulative frequency graph. Okay, so we have the cumulative frequency graph on the screen, and we're going to fill in the minimum, lower quartile, median, upper quartile, and maximum. The minimum data value is 10. The lower quartile, well, the total number of data points is 40. You can see it flattens off at 40. And the quarter of 40 is 10. So we go across from 10 and down, and we get that the lower quartile is 25. The median, half of 40, is 20. We go across from 20, and then we go down, and we read off the value of the time, which is about 34. We go across from 30, that's 3 quarters of 40, and we go down, and we get the upper quartile is 38. And then the maximum is the 40th value, which is 50. On a number line, it will look like this. The minimum is 10, the lower quartile is 25, the median is 34, upper quartile is 38, and the maximum is 50. This is what our box and whisker plot looks like, our box plot looks like. Now it's time for you to have a go yourself. So I've got a data set for you to try. I'd like to draw an accurate box plot for this data. You will need a ruler, a pencil, to do this accurately. You can then comment on the data, mention its skewness and dispersion. Pause the video now and try this yourself. When you're ready, I'll reveal the answers in 3, 2, 1. Did you get it right? Let me know how well you did in the comments below. Thanks for watching this week's video from Advanced Maths. Remember to like and subscribe so you don't miss any future videos. We're covering GCSE, A-Level and IB Maths with quick and simple explanations, and new videos will be coming very soon. Also check out advancemaths.com for more help with your revision. Thanks for watching and good luck in your exams.